Google just made headlines around the world, including the world's richest man Elon Musk, with the announcement of its new quantum chip called Willow. In a post on December 9, Hartmut Neven, founder and head of Google Quantum AI, said that the Willow chip opens the door to the development of large-scale quantum computers. He emphasized, Willow can bring huge benefits to society, from accelerating scientific discoveries, developing useful applications, to solving the biggest challenges facing humanity. After Alphabet CEO Sundar Pichai announced Willow on social media, Elon Musk was extremely surprised. The conversation continued when Pichai suggested, "We should build a quantum cluster in space with Starship one day." Musk replied, "That will probably happen. The computers that users have been using every day for decades are called classical computers. Basically, classical computers use binary as their basic language. A bit, the smallest unit of data a computer can store and process, is like a light switch. Each bit can only be in one state at a time, either on or off, represented by a 0 or a 1. Computers keep track of data in the language of bits. Literally everything our computers do is based on a network of on-off switches sending a specific signal. Quantum computers, on the other hand, are a little different. Each quantum bit, or qubit, can potentially represent multiple states at once. Instead of recording just a 1 or a 0, it records both because it can be both. This allows a chip like Willow, which has 105 qubits, to perform incredibly complex analyses in a fraction of the time it takes a classical computer. For example, if you have 2 bits that can return a value of 1 or 0, there are 4 potential states that can be recorded: 00, 01, 11, and 10. If each of these states takes 1 second to record, it would take a classical computer 4 seconds to record every possible permutation. However, a quantum computer made up of 2 qubits would be able to record the potential of each qubit at the same time. That is, it could record all 4 possible states in 1 second. When Willow was announced, Google Quantum AI founder and director Hartmut Neven said the new chip had performed a deliberately complex exercise called the random circuit sampling benchmark for 5 minutes. On the other hand, one of the world's most advanced, classical, supercomputers would take 10 septillion years to complete the same task. What makes Willow special? Neven says that's 10 quadrillion years, which is beyond the known timescales in physics and far beyond the age of the universe. The reason Willow can achieve such a significant improvement in computing power is because Willow is made up of 105 qubits and can monitor the potential of each qubit at the same time, allowing it to record potential data much faster and deliver the correct answer sooner. Google adds that quantum computing's ability to analyze multiple sets of data at once could help solve some of our biggest problems. Willow represents a major step forward in applying quantum technology to solve humanity's most pressing problems. One of the biggest promises of quantum computing is its ability to analyze and process data at unimaginable speeds, leading to rapid and efficient solutions to problems like climate change, drug development, and energy optimization. For example, climate change is not just an environmental issue, but also an economic, social, and political one. Willow, with its ability to analyze short-term climate scenarios, could help scientists and policymakers find more effective strategies to reduce emissions. In addition, the technology could aid in the design of new, environmentally friendly materials that reduce our dependence on fossil fuels. In medicine, Willow could revolutionize the search for new treatments. The power of quantum computers lies in their ability to analyze complex molecular structures quickly and accurately, something that classical supercomputers cannot do. This is especially important when developing new drugs, as each drug molecule needs to be tested across a wide range of scenarios and conditions. Willow also has the potential to analyze large amounts of medical data, helping to identify disease patterns and develop personalized treatment plans. For example, cancer, one of the biggest challenges in medicine, could be diagnosed and treated more effectively thanks to the powerful computing power of quantum. Willow promises to improve energy efficiency on a large scale, from optimizing power grids to developing new generations of batteries. Designing more efficient batteries not only reduces costs but also extends product life, thereby promoting the development of related industries such as electric vehicles and renewable energy. Quantum computers can also help solve complex problems such as forecasting energy demand or optimizing energy production and distribution. This is especially important as the world transitions to cleaner and more sustainable energy sources. Beyond science and medicine, Willow has the potential to be applied to many different fields. In finance, quantum computing capabilities can revolutionize risk analysis and market forecasting. In logistics, Systems like Willow can optimize complex supply chains, helping to reduce costs and improve operational efficiency. In addition, the defense and cybersecurity industries can also take advantage of this technology to develop unbreakable encryption systems to deal with increasingly sophisticated cyber attacks. With such great potential, Willow is shouldering great expectations from society and academia. However, this also puts pressure on Google and other technology companies to turn theory into practice. For quantum technology to truly benefit the community, businesses need to invest more in infrastructure and promote cooperation with governments and nonprofit organizations to develop practical applications. Google has wisely opened the source code of the software and provided online courses, aiming to strengthen the development capacity of the scientific community. This is a strategic step to promote the spread and acceptance of quantum technology in society. Although Willow is impressive, it is not the most powerful quantum computer today. Instead, a company called Atom Computing has created a computer exceeding 1,000 qubits. Willow is a quantum chip that can solve complex problems that would take a conventional computer longer than the age of the universe to complete. These problems, called benchmarks, are used to compare the performance of different types of computers. What makes Willow stand out is its ability to learn from and reduce errors as it performs. While conventional computers often make mistakes while solving problems, Google claims that Willow becomes smarter as it uses more qubits, the computing units in quantum computers. Hartmut explains that Willow reduces errors exponentially as it scales, solving a challenge that has been plaguing the field of quantum error correction for nearly 30 years. Nevin likens Willow's capabilities to a pencil with a super-fast eraser. It can correct errors in real time, allowing quantum computers to perform calculations perfectly, eliminating mistakes as they occur. This is the most convincing prototype of a scalable logical qubit ever built. He said, "It is a strong signal that very large and useful quantum computers can indeed be developed." Willow's notable achievements. One of Willow's biggest achievements to date, according to Nevin, is solving a problem in just 5 minutes. That may not sound impressive, but Google claims that it would take a conventional computer 10 trillion years to solve. It's this ability that makes Google believe that Willow has the potential to create breakthroughs in new drug discovery, next-generation battery design, and global energy conservation. While many tech companies, including Google, have been criticized for overhyping their quantum inventions, Willow has been met with great anticipation. To expand its reach, Google has made its software open source and launched a course on Coursera to help developers, engineers, and researchers create algorithms that can solve future challenges. The fact that Elon Musk, a figure who is often seen as a symbol of innovation and vision, was surprised by Willow shows that Google has surpassed the expectations of even industry leaders. Willow is not just a technological achievement, but also an affirmation of Google's position in the race to master quantum technology. This puts pressure on Musk and his corporations, from Tesla to Neuralink, to maintain their pioneering role. Sundar Pichai's idea of combining a quantum cluster with SpaceX's Starship is a bold combination. A quantum cluster operating in space could open up unprecedented possibilities in the field of space science, such as simulating the behavior of materials in zero-gravity conditions or planning space resource exploitation. This could be a rare opportunity for collaboration between two giants who operate independently in different fields. However, this collaboration will require a delicate balance between the interests and technological security of both parties. Despite the positive signs from the conversation between Musk and Pichai, it is still possible that Elon Musk will see Willow as a challenge. SpaceX, Neuralink, and Tesla may need to invest more heavily in quantum technology to ensure that they are not surpassed by Google in applications related to AI, advanced computing, and space technology. While Tesla is focused on AI and autonomous vehicles, integrating the power of quantum computers like Willow could be a strategic move to speed up development and optimize performance. Challenges for Elon Musk and the technology world. Google has demonstrated superior capabilities in the quantum field, while Elon Musk's companies such as Tesla and SpaceX have not announced any initiatives in this field. This puts pressure on Musk to reconsider his long-term strategy. Can the AI Tesla is developing take advantage of the power of quantum? Can Neuralink, which is aiming to connect the human brain to computers, cope with the pace of Willow's development? Quantum computing is not just a faster technology, but also has the potential to change the way AI learns and makes decisions. In this context, current AI systems, including OpenAI, where Elon Musk once played a key role, are at risk of becoming obsolete if they do not quickly adapt to the new environment. Willow's enormous computing power will allow complex AI models to be trained in a short time, something that would take years for classical computers. This poses a difficult problem for Musk: how to integrate and take advantage of quantum in his products. Elon Musk has repeatedly warned about the risk of losing control in the development of technology, especially AI. Willow's emergence has raised concerns that quantum computers could break current encryption systems, leaving personal information, financial data, and even national security vulnerable. That's the challenge Musk and other tech leaders face: how to balance the potential and risks of quantum technology. While Google has touted Willow as a milestone in quantum technology, skepticism remains, claiming that Willow can solve a problem that would take a classical computer 10 billion years in just 5 minutes may be an impressive demonstration of computing power. But does it really have any practical significance? Some scientists point out that the random circuit sampling benchmark problems that Willow solves are specifically designed to optimize the performance of quantum computers, rather than real-world problems that society faces. In fact, Google has been criticized for overstating the capabilities of previous quantum technologies. In 2019, when Google claimed to have achieved quantum supremacy with a different chip, the scientific community argued that the problem solved had no obvious practical application. Willow faces a similar dilemma. Can it move beyond the technology demonstration stage to create real value? Or is it just an exciting scientific milestone without profound impact? In addition, Google is not alone in the quantum race. Companies like IBM, Microsoft, and even less prominent names like Atom Computing have made significant, even outstanding, advances in some areas like qubit count. This raises the question: is Willow really leading? Or is it just part of Google's grand marketing strategy? Finally, while Google has emphasized that Willow has the potential to solve global problems like climate change or cure incurable diseases, applying quantum computing to these areas remains a major challenge. Issues like correcting quantum errors in real-world environments, reducing operating costs, and building optimized algorithms still require years of research and development. It is these limitations that make bold claims about Willow need to be viewed with more caution and consideration. Whether Google's bold claim of evidence for the existence of a multiverse will stand up to scrutiny remains an open question. But there's no denying that the Willow chip represents a major step forward in the field of quantum computing. It not only pushes the boundaries of computer science, but also teases our imaginations about the infinite possibilities of the universe. Are we really living in a multidimensional reality where countless versions of ourselves exist side by side? Perhaps only time and further advances in quantum research will answer this fascinating question.